All right, welcome to Math 135, R.5, negative and rational exponents. So hopefully we've already seen this before, but if not, here's some review. Or at least it's a review if you've seen it before, and if not, here we go. All right, so exponents. There are a few different rules. This one is called the product rule. And a good way to notice what it is if the bases are the same and we are multiplying, we'll just add up the exponents. So you keep the base, and then you add up your exponents. The next one is called the zero exponent. Now this is when you have 0 for your exponent, the answer is 1. And note, this is for a not equal to 0. All right, so for power rules, a few different rules. This first one, if you're only working with one base and two exponents, keep that base, and what do? We multiply the two exponents together. Next, if we're working with two different bases, and they're both being raised to the same power, what happens is we just give each of those bases that new power. Next, if we have a fraction going on, again with two different bases, and they're both being raised to this certain power, we split the power up, and they each get that same power. And again, this is for b not equal to 0, because we cannot have 0 in the denominator. So let's take a look at example 1 and work on simplifying. Again, feel free to pause the video and practice on your own, and then check back in with me when you turn on the video. So let's see. We have negative 4 divided by 5 squared. Okay, so that negative is on the outside, so we'll leave that alone. And let's go ahead, see, and which rule should we use? So let's go ahead and work with this rule right here. So we'll go ahead and distribute that 2 to both the base and the numerator. And then we'll have negative, so 4 squared is 16, and 5 squared is 25. And we are done. The next one. Ooh, this time the negative is inside. So what does that mean? Well, that negative also gets to have the exponent. So you can think of this as negative 1 times 4 over 5 squared. Let me move this over here so we can see our work. Which means we're going to have negative 1 squared times the 4 over 5 squared. And we already know how to do that, so it's negative 1 squared is 1 times the 4 squared over 5 squared, which is going to be 1 times the 4 squared over 5 squared, which is just going to be 16 over 25. Now the next one. Again, we're just going to distribute. So the top will get distributed, so we get 4x squared divided by the 5xy squared. And now we're going to go ahead and use this rule right here. So it's going to be 4 squared times x squared divided by 5 squared times x squared times y squared. So that'll be 16x squared divided by 25x squared y squared. Now we might be done, but careful, we can simplify those x squareds. Since they're the exact same, we can cancel them out from each other. Boop, boop. And we are left with 16 divided by 25y squared. All right, so now let's take a look at another rule, which is negative exponents. And I consider this, or I call this fish out of water. So with this negative exponent rule, think about something. If you take a fish out of the water, what do we know has happened? Well, more than likely, your fish is unhappy. It is a negative fish, right? How would you make that fish happy? We'll put it back in the water, right? So think about the fraction bar as being like the water of the ocean, right? You're going to put it under a fraction with 1 at the top, and then your fish becomes a happy fish. Just a cute way of remembering it. So whenever you have a negative exponent, make it happy, put it under the fraction bar, it'll be happy. The next rule we have is the quotient rule. So if you have the same base, same a, what you'll do is you'll take those exponents and minus them. And this is for a not equal to 0. So let's take a look and practice simplifying. We have 2 to the negative third power divided by 7. Well, I'm going to break this into two different things so it simplifies a bit. We know we can split this into a 7th times 2 to the negative third. Now, to simplify that 2 to the negative third power, we'll use the fish out of water rule. We'll just bring along that 1/7 and then fish out of water rule. To make that negative a positive, we'll put it under 1. So it'll be 2 to the positive third power. Now we'll go ahead and multiply them back together. We have 1 over 7 times, and what's 2 to the third power? 2 to the third power is 2 times 2 times 2, because we're writing out 3 times, and that's going to be 2 times 2 is 4, bring down that other 2, and 4 times 2 is 8. So times 8. Let me go ahead and erase this here. Okay, and then multiplying the 7 and the 8 together, we get 1 over 56. Just waiting for my pen to cooperate. All right, there we go. 1 over 56. Let's take a look at the next one. Okay, so now this time that negative 3 is being applied to this entire base of 2 over 5. So we're going to go ahead and once again apply it to the numerator and the denominator. And then what happens here? We're going to be taking the reciprocals of both of these. Again, another way you can think of a fish out of water rule is you're taking the reciprocal. So I'm going to break these up so we can see them a little better. Again, just the trick we did earlier. And then we'll go ahead and take the reciprocal. So to make this a positive, we'll take the reciprocal, and again, as usual, we'll take the reciprocal here. So that'll be 5 to the third power times 1 over 2 to the third power. And then we'll go ahead and write those out, 5 to the third over 2 to the third. Again, just multiplying those together. How would we figure out what 5 to the third is? We already know 2 to the third, that's 8. 5 to the third, again, we'll just go ahead and write that out. So 5 times 5 is 25. Bring down that other 5. 25 times 5, that is going to be 125. Okay, and then we're done with that. Go ahead and erase that. And we cannot simplify between the 5 and the 2, or I mean between the 125 and the 8. So we're done. If you have a fraction and you can simplify it by dividing the top and the bottom by the same number, please do so. I do grade for a simplified fraction. All right, let's take a look at this next one. Ooh, this is kind of strange. We have some variables in here now. So let's see. For now, I'm going to ignore those variables and just focus on this parenthesis going on here. I'm going to go ahead and distribute that 2 to both of the bases, that 3 to the negative 1 and that y. So we'll get 3 to the negative 1 raised to the second power, and then y to the second power as well. Okay, and then using the power rule, I'm just going to write these guys down. Using the power rule here on that 3, we can keep the base and then we multiply those two together. So that will give me 3 to the negative 2 and then times y squared. All right, so now I'm going to use the other rule up here, if I can find it again. Right here, we have the same base going on and we're going to add the exponents. So I have the same base y, and I'm going to add up their exponents. But what is negative 2 plus 2? That's going to be 0. So my y's are gone. Anything to the 0 power, again, is 1. So let me write this out, actually, so you can see it. That's going to be y to the 0 power and 3 to the negative 2. And again, remember, anything to the 0 power will be 1, so that will actually end up being gone. And this is x times 3 to the negative 2. One thing to note, please, as you're showing your work, if you have to move along and you're running out of space to write, please just use that little arrowhead to show me the direction that you went. All right, moving on. We still have that negative 2 to get rid of, and I'm going to use that reciprocal rule, or fish out of water, so it'll be x times 1 over 3 to the second power. And then I'll go ahead and just multiply these two together and get x over 3 squared. We're not done, so I'm going to go ahead, show where I'm going with my arrow. Again, please use an arrow to show me where you're going. And then 3 squared is just going to be 9, so that's x over 9. Okay, moving along. So let's take a look at rational exponents. So we have an expression, a to the 1 over n power. If n is an even positive integer, where a is greater than 0, then we can just go ahead and cancel out the fractions. Okay, again, some rules here. If n is even, which means this little number here and here, if they're an even number, and our a value is greater than 0, then we can just cancel them out and our problem equals a. For example, a being greater than 0, let's go ahead and pick 3. And then we have 3 raised to the, what's a positive, or what's an even number for n? Let's pick a 2. So if 3 raised to half power and then squared, what can happen? We can cancel these guys out, and we're just left with an answer of 3. But again, the rules for that is this needs to be greater than 0, and these two need to be even. Let's take a look at the other option. If n is an odd positive integer, then what happens? Well, we can still cancel them out, and it equals a. All right, good to know. And again, this is if they are the exact same, if the denominator is the same as what it's being raised to. And the other thing to note from rational exponent is a to the m divided by n can be written in 2 different ways. We can write the fractional exponent first, raised to the numerator, or we can do the numerator first and then put the denominator on the outside. 2 different ways we can split up this little fractional exponent, which is very useful. Example A, let's go ahead and simplify. We have 8 to the 1/3 power. Again, what do we know about the 1/3 power? Well, the 1/3 can be written as, oh, and I didn't notice this, or I didn't write it down. A to the nth power is the same thing as the nth root of a. So the denominator is the radical. So this here means the cube root of 8. And what is the cube root of 8? Well, let's see, that's going to be 2. Again, what is the cube root asking? What times itself gives me 8? So we have to figure out what times itself, how many times? 3 times would give me 8, and that answer is 2. All right, so let's take a look at B. What do we notice is going on with B? Well, we have a negative on the inside. It's a negative 32. And it's being raised to an odd positive integer. So in this case, we're probably going to be looking at this example. And then what do we know? Well, if we can raise it to the 5th power, we could cancel and use this rule. Why do I say 5th power? Because again, we have a denominator of 5. So what are ways we can write this? Well, 32. What do I know about 32? 32 is the same as 2 to the 5th power. Is it also the same as negative 2 to the 5th power? It is, and I'll go ahead and show you. Let's see, how many times negative 2, oops, negative 2 times negative 2. We have 5 negative 2's. The first 2 multiplied together would give me a positive 4. Second 2 multiplied together would also give me a positive 4. Bring down that negative. Positive 4 times positive 4 is 16. Bring down that negative 2. 16 times negative 2 is negative 32. Aha, good. So, negative 2 raised to the 5th power would be negative 32. So this is negative 32. Oh, sorry. That's negative 2 raised to the 5th power. I've changed that to this. But it's also still raised to the 5th power. So I can go ahead and use this bottom rule. Cancel those 5's, and what's left over? Negative 2. All right, let's take a look at C. What's going on here? We have 7, base 7, 3 different base 7's. And they're being raised to different powers. And then we have 2 base m's. So I'm going to be using that product rule to simplify out with the base 7's. The first one I see is 7 to the 3rd power times the 7 to the 2/3 power. So I can keep the base 7 and add their 2 exponents. And then I'll just do the m to the negative 2 over 7 to the 3rd, m to the negative 3. Thankfully, these two fractions have the same denominator, so we can just add through, and we will get 7 to the 3/3 power. All right, and after I've done that, I'm going to go ahead and simplify my m's. We'll use that one of the quotient rules. We can keep the base and subtract the exponents. So I'll keep the base of m, and then I'll have the -2, and I'm going to subtract from it that -3. And then we still have that 7, or the third power on the bottom. All right, let's do some more simplifying. 7 to the 3/3 power is going to be the same as 7 to the 1 power, because the 3/3 simplify. And then these simplify out to m to the first power, because that's -2 plus 3. And on the bottom, we still have that 7 to the third power. Can we simplify anything else? We can. We still have 2 base 7s. So we're going to use that quotient rule again. Or, actually, a simpler way would be to just cancel a 7 from the top and the bottom. So we'll take away 1 7 from the top, and we'll take away 1 7 from the bottom, which leaves only 2 in the denominator. And we have m over 7 squared. And we're done. Again, there are different ways to do these problems, so if you have a different method and you want to know if it's correct, again, send me an email. So let's look at D. Now my plan, whenever I see parentheses like this, I like to see if I can simplify the inside. But currently I can't because all these bases are different, so that plan didn't work. But that's okay, I have more plans. Let's see, it seems all we can do is distribute out that 1/5 to all of the different terms. So let's go ahead and do that. That'll be x to the 10th to the 1/5 power over 32. You know what? I'm going to change 32 to 2 squared. Why would I do that? Well, I see that 1/5 coming, and I know that could simplify with it, so I'm going to go ahead and do that. And then we have y to the -5 over 2. And again, all of the bottom ones are still being raised to the 5th power. Oops, I didn't leave a lot of room. Okay, and then we'll use the power rule, multiply between the exponents. That'll be x to the 10/5 divided by 2 to the 5/5 times y to the negative, what would that be? -5/10. Okay, so now we got all these fractions going on. Can we simplify any of them? We can. That will cancel with that, and that's a 5. Those cancel to a 1, and this one cancels to a 1/2. So let's see, what do we have? We have x to the 5th power over 2 y to the -1/2 power. And we can't have negatives in the denominator for the exponents, so we got to bring that y up using that reciprocal rule. So when we make the reciprocal, it becomes a +1/2 over 2. Alrighty, and we're done. That's all we can do. There's no other like terms to simplify with, no other radicals to simplify. Let's take a look at E. What do we have going on here? Again, always spend some time looking at the problem and identifying the different things you see. I notice we have the fractional exponents, and then we have some parentheses going on, and so I'm multiplying these different groups together. And let's see, can we subtract these terms? No, we can't. They're not like terms. We can't subtract. And we can't add these. So the only thing we can do is multiply them out. So let's go ahead and do some FOIL. So the first term times the first term. It's going to be n to the 3rd times n to the 5/3. That's this term. And then let's see. Plus, so first outside, these two together. N to the 3rd times n to the 2/3. So first outside, inside. And again, I said FOIL. That's what we're doing. Let me write that out so you see what I'm saying. FOIL. How you multiply two different binomials. Again, I'm just assuming that this is review, and if this is something you need help with, again, just send me an email and I'll send you a review sheet. Okay, again, so we're working with FOIL. So I did the first, I did the outside terms. Now I'm going to do the inside terms, these two. That'll be n to the 2/3. Oh, that's a negative n to the 2/3 times n to the 5/3. And then last, this term times this term. So plus, and then we have still that negative n to the 2/3 times n to the 2/3. All right, okay, let's go ahead and multiply this out. Again, we're keeping the denominator and adding the exponents. Now, these exponents thankfully all have a base 3 or a denominator 3, which means they're like term fractions. like term. They have the same denominator, so we can just go ahead and add. So this would be n to the 1/3 plus 5/3, 6/3, plus n to the 3/3 minus n to the 5/6 minus n to the, what is that, 4/3. So simplifying the fractions, that's a 1, that's a 3, that's just a 1, that's a 2, and this one doesn't simplify. So we're left with n to the 3rd plus n minus n squared minus n to the 4/3. Can we combine any like terms? None of these are like terms, so we are done. You could technically try to write them in descending power if you wanted, which would probably be n squared minus n to the 4/3, because n to the 4/3, let's see, 4/3 is technically the same as 1 1/3. And then plus n. You could do that too. I would be fine with this. Alrighty, so let's see. Moving on, last part, factoring with negative or rational exponents. So, one thing to note, when you're factoring something out, choose the smallest number exponent that you see. Okay, main thing to keep in mind. So this first one, for factoring completely, let's see, how would we factor this? Well, notice, again, we're talking about negative exponents, but don't worry, we can factor those. And again, the tip is to choose the smallest. Which one's smaller, -3 or -5? Now be careful, remember, on the number line, -5 comes first. So -5 is technically the smallest. So we're going to factor out n to the 5th. N to the -5th. And the question would be, what is left? So this can be a little tricky. Remember, just take a moment, breathe, you can figure it out. So what you might ask yourself is, if I were to factor these back in, I want to end up with n to the 3rd power. So n to the -5th times n to the what would give me n to the -3rd. And remember, when you multiply, you end up adding the exponents. So it's just the same as asking yourself, -5 plus what gives me -3? The answer would be 2. -5 plus 2 equals -3. So when we factor out -5, the -3 is left with n to the 2. And then -4 times, and we already factored out the -5, so that's it. And I'll go ahead and erase that. So let's see, ask yourself, did we actually do this correctly? Let's check by multiplying it back in. So here's me checking. Okay, we're going to distribute that in, so n to the -5th times n to the 2, keep the base, add the exponents, and then that times that, that's going to be 4n to the -5th. Adding these exponents, we get n to the -3 minus 4n to the -5th. Yep, that's what we started with, so we're good. All right, I'll go ahead and erase our checking, and that's what we would do. So again, sometimes you have to do a little bit of backwards thinking to find the right way to factor it. There, again, are other ways. This is the way I like to think about it. But if you have a different method, or if you have a question on other methods, I can show you those as well. So now let's take a look at this one. Ooh, the game has been bumped up a bit. Now we have fractions. But again, the goal is to pick the smallest one. And which one is the smallest? Aha, that would be the -1/2. So we're going to go ahead and factor that out. X to the -1/2, and then what is left over? Well, for this first term, let's ask ourselves that question again. X to the -1/2 times x to the what would give me x to the 3/2. Or, another way to think of it is -1/2 plus what would give me 3/2. How about 4/2? 4/2. 4/2 minus 1/2 would give me that 3/2. Okay, so again, let's go ahead and do that. That's going to be x to the 4/2, which is technically the same as what? 2. So x to the 2 minus. Okay, let's go ahead and do the same thing again. This time we're looking at x to the -1/2 times what gives me a +1/2. And again, that's the same as this, sorry, a negative half plus what gives me a half? 2 over 2, right? 2 over 2 plus negative half would give me a half. And again, that's the same as 1. So that's going to be minus 3 times x to the 1 power. Plus, and for this last term, we factored out that half. So we're just left with the 2. And again, if you want to make sure that you did your factoring correctly, how would you do that? You would check it by just distributing it back in. So let's go ahead and just check. Because, it's easy to make mistakes on this one. So I would really suggest that you check these. Okay, let's go ahead and distribute this in. That times that's going to be x to the negative half times x squared. And then we're going to do this. Minus 3x times x to the negative half plus 2 times x to the negative half. Okay, now to change these exponents so that we can try and see if they add up together, I'll change the 2 into 4 halves. And then the x to the 1 power would be 2 over 2. So let's see, that's going to be adding up the exponents. We get x to the 3 halves minus 3, and adding up these exponents, we get x to the half. And then that's left over, so 2x to the negative half. Is that what I started with? It is. Okay, awesome. So again, working with these fractional exponents, you really have to remember how to add and subtract fractions. So again, if you need any help with that or any extra resources, please email me and I will gladly send those to you. A lot of small fractions to deal with. So just write that in, boop, boop, and we're done. Now let's take a look at C. Ooh, this one's even more of a step up. We have the fractional exponents and we have binomials. The binomials are the same, but the fractions are different. So again, when we're factoring, we're going to factor out the smallest one, yep. And which one's the smallest? It's that negative third is the smallest. If you picked that, awesome, good job. If not, it's okay, you're still learning. All right, let's go ahead and factor that out. Feel free to pause the video and try it out by yourself. Okay, so when we factor that out, what is left? Well, remember, we're trying to think. X plus 3 to the 5/3 power, we're trying to get that. So, x plus 3 to the negative 1/3 power times the x plus 3 to what power would give me that? And what are we looking for? Technically, remember we add our exponents to get this exponent. So it's going to be negative 1/3 plus what? Gives me 5/3. 6/3. So negative 1/3 plus 6/3 give you 5/3. This is what we're going to use for our exponent. So, okay. Remember, we still have that x plus 3 left. We just have a new exponent of this, 6 to the 3rd power. Minus, and then we factor this whole thing out. So what's left? Just a positive 1. Okay, so let me write this out again. We have x plus 3 to the negative 1/3 times x plus 3 to the, well, I could simplify that. That would be 2 minus 1. And again, if you wanted to check if you were correct, you could go ahead and just distribute this out, and then you would see if you were right or not. But other than that, we are done. Actually, close. We're almost not done. We need to factor this out and then add that negative 1 to it. So let's do that real quick, since we can. So that's going to be x plus 3 times x plus 3 again. Factoring this out, it splits into that, and the minus 1. That'll be x plus 3 to the negative half times x squared plus 6x plus 9 minus 1, which is x plus 3 to the negative half times x squared plus 6x, and lastly, plus 8. Whew, okay, that was a lot. Are we done? Can we factor? Again, our goal is to factor. Now, you might be tempted to say we're done, but careful. Can we factor this trinomial? The answer to that is we can. All right, so again, the question is factors of 8. How can we add them to get a 6? Let's see, we could do, let me just write this down first before I factor. That factors into x plus 4 times x plus 2. Alrighty, and now, okay, yeah, those are all factored. And that's it. I'm done with my problems. Well, not with all problems, but at least with these problems. Okay, so that is it for section R.5. If you have any questions again, please feel free to email me.